No, we're going to come back to it. I kind of explained at the beginning of class, I guess you missed it, that we're skipping trig, we're going to come back to trig. Yeah. So the reason exponential functions are important is because exponential functions model lots of important things that you would study in math and science. Exponential functions are included in things, in problems studying population and money. Money grows exponentially. So if you go to business school, you'll study lots of these types of equations. This is what the exponential function looks like, and I kind of drew it on the board, and here it is again. So we'll do some graphing, but we'll do some more graphing tomorrow. And here's another exponential function, this one, right? So it's a nice, it can be gradual, a gradual rise up, or it can be sharper, depending what the base is. It actually can be flipped over too if there's a reflection. But this is what the basic exponential function looks like. So you can see why it would be a model for population, right? Population growth starts off small. If you have two parents, we'll say, right? And they have offspring, but then their offspring have offspring. And the population tree just keeps growing and growing. So population growth might start off small, but then it just keeps growing much more rapidly. So let's go to our review of exponents, and I'm on page 224. So there are rules of exponents. Sometimes they're called laws of exponents. So we're going to review these, work through a few examples, and then I might actually give you a couple more examples too. But you may recall from earlier math courses that exponents are really shorthand for multiplication. For example, instead of writing 3 times 3, we write 3 to the power 2, right? Or 3 to exponent 2, or 3 squared. 3 2's multiplied together, I would record as 2 to the power 3. The exponent is a number that tells how many times the base itself is multiplied by itself. This is called the base, right? The 5 is the base, and the 4 is called the exponent. Okay, and I'm going to give you an example. Well, they've got a real, they don't have a real world example here, so I'm just going to do this. Let's do another real number example. Let's do another one. So if I had 3 to the power 5 times 3 to the power 4, that could be simplified to 3 to the power 9, right? And then you would pick your calculator up and go 3 exponent 9. If I'm just simplifying, it's the simplified form of these two, right? So they've got x to the 2 times x to the 3 is x to the 5. Notice this, y to the 3x minus 1 times y to the x minus 2. Because they're both the same base y, I add the exponents, I add the two binomials, and I end up with 4x minus y as the answer, okay? These two students can get confused, but to me they look completely different. This is called power of a power, right? Power of a power. And when we have power of a power, we multiply the exponents. Can you see the difference? This had 2 bases, right? I'm multiplying two bases, 2 of the same bases. We add exponent. Here, there's only 1 base, so the exponents are multiplied. So their examples are x to the 4, all raised to the power 3. That simplifies to x to the 12. 2 to the y, all raised to the power 4 is 2 to the 4y. Okay? Again, here now we have dividing 2 bases, divide 2 bases, divide same base, so this is actually the opposite of rule 1, right? We have the same base multiply, so we add them, same base divide. It kind of makes sense to me. We subtract the exponents. And the examples they showed us, I have x to the 12 over x to the 5. That simplifies to x to the 7. Here I have some x's on the top and bottom, and y's on the top and bottom. 3 minus 2 would be x to the power 1. 2 minus 1, remember when there's no exponent indicated, it's an exponent 1. 2 minus 1 is 1. Again, x, we would just record this as x times y. We don't write the exponent of 1 for the final answer. Okay? Now, this is just to tell you that the power outside a set of brackets applies to each power inside. So remember, this is power of a power twice. So this is x times a to the power ac, b to the power bc. Okay? This can be tricky. Don't forget that this 3 applies not only to the base y, but base 2, right? So this would simplify to 2 to the power 3 times y to the power 9, which would simplify to 8y to the power 9. Okay? Yeah? And again, a power outside a division statement, the power applies to both numerator and denominator, giving us axac over ybc. Now they've introduced us to 2 negative exponents here, right? Your final answer can't have negative exponents in it. But in the middle of a question, you might have some negatives, right? So just go apply the rules as you would. So negative 3 times negative 1 is positive 3. Negative 4 times negative 4, positive 4. That leaves us with x to the power 3 over y to the power 4. So no need to change anything, right? They ended up being positive. Agreed? Anything raised to the power 0 is 1. We've mentioned that numerous times in class, I think, right? Even if I had something like this, like something crazy, like 1, 2, 5, x to the power 7, y to the 12, z to the 3. If everything is raised to the power 0, this all just becomes 1. Yeah. And then this is converting from radical. Convert from radical to exponential. And that's going to become an important skill in this, I'm just going to erase this for a sec, in this unit, because sometimes they might sneak in a question with the radical sign. In order to apply exponential logs and to do math with exponents, you have to be able to convert from radical to exponential. So the nth root of x to the power m becomes x to the m over n, right? So the cube root of x to the power 4 becomes, the x to the 4 stays, it's just the index becomes the denominator of the base, the exponent of the base. Let's try another one. How about this one? This is, what's the square root of 16 written in exponential form? 16 is my base. What's the power on the 16? It's just 1, so the 1 stays over 2, right? The cube root of 8 can also be written as, okay, base 8, the power was 1, the index number becomes the denominator, right? So x to the power 1/3 is the same as the cube root, right? So that's a skill that you have to be able to do quite quickly. I'm going to add just dealing with negative exponents, because you have to be able to just record, all your final answers should be with positive exponents only. So if I end up with something like this, x to the power of negative a, to convert to a positive exponent, I just write it as its reciprocal. So it would be 1 over x to the power a. Right? That's how I deal with that. If you end up with this, let's try this one. If I had 1 over x to the negative b as a final answer, I wouldn't leave that with a negative exponent. Writing 1 over x to the negative b, its reciprocal would be x to the power b over 1, or just x to the power b. So one of the quick ways to explain it is, If you have a negative in the numerator, just move it to the denominator to become positive. If your negative exponent's in the denominator, move it up to the numerator for it to become positive. That's about it. That's how we handle it. Okay? One more example up here, and then we're going to try these without looking at the answers, and we'll see how we do. So again, this is just the generic form of moving from radical to exponential, right? Your x to the power m stays. It's just the root sign becomes the denominator, and they've given you another example here, right? The x squared stays, the 3 just becomes the denominator. Okay, so let's try a couple of these. And then I'm going to stop, and I'm going to, we're just going to do, this is all just review, like grade 10 review, I think. Okay, once again, they've given us the answers, but we don't want to look at the answers, right? So cover the answers up, and we're going to try this. It says, write the following expression, so simplify, without any brackets. Basically, that's the way of saying simplify, and your final answer should have positive exponents only. So this expression, this term, consists of coefficients. It's got pairs of bases, same bases, right? It's got x's, y's, and z's. So if there's coefficients, I usually do those first, because that's what I come to first. So 36 divided by negative 6 is just negative 6, right? Okay, same bases being divided, so what do I do with the exponents? Subtract, right? 6 minus 5 would be x to the power 1, right? Negative 3 minus 2 would be negative 5, right? And then 7 subtract negative 2 would be what? 9. 7 subtract negative 2 is 9? Okay. So now, is this a good enough answer? No, I've done the math right, but I have a negative exponent. So how do I handle a negative exponent? I just move him. I wouldn't write my x to the power 1. It's just understood that it's x to the 1. So x to the 1 stays up top, so does z to the 9. The y moves downstairs, so I can write it as a positive 5. Agreed? And that's it. That's my final answer.
Excuse me.
Yeah.
You said it as 7 subtract that negative.
Yeah.
What?
7 subtract negative 2 is 9. Okay. Okay, so now what we have here, this is slightly more complicated, this one. Well, would you agree or no? Well, first of all, there's 2 terms I'm multiplying, but even before I multiply the terms, I have a power, right? So laws of exponents follow BEDMAS. I deal with exponents first before I do the multiplication, right? So I have to deal with this power first. So the power applies to all pieces inside. Now, this is interesting. I've got a division statement and I've got exponents. Really, it's kind of up to you. We could do our division statement first because it's inside brackets. Do you know what I mean? Should we do that first, Joanna? So we'll do anything we can inside the brackets following BEDMAS before I do the exponent. So I can do some cleaning up here, right? This would be negative 4. 2 minus 1 would just leave me with an a. 4 minus 1 leaves me with b to the power 3. Agreed? And then I have to square this first. Let's see if I can do any simplifying inside here. I think I can, can't I? 27 divided by negative 32. I don't think I can do anything there, so unfortunately I'm going to have to leave that. How about the a's? A to the 5 over a to the 3. What does that become? Exponent 5 on top, exponent 3 on the bottom. A squared on top, right, Carl? How about b to the 8 over b to the 6? On top, right? Okay. So now what I have to do, now I'm going to apply this exponent. So this is going to be negative 4 squared is what? What's negative 4 squared? Positive 16. A squared, b to the power 6. Okay, Okay, times, this is a big one, 27 over negative 32, a squared b squared. Okay, the nice thing is I don't have any negative exponents, right? When you're multiplying fractions, this is like a 16 over 1, right? I can cancel any number on top with any number on the bottom. I can do factoring out, right? So the 16 cancels out nicely. I'm left with negative 2, right? So my final answer will be negative 27 over 2. Because it doesn't matter where the negative goes. It could go up with the, it's actually better just written out to the side because it belongs to both of the numbers, right? It belongs to the fraction. 27 over 2 represents one number, right? It's 27 divided by 2. So I'm going to put the negative sign right out here where it should be. Okay, then I have a squared and a squared, same base, I add the exponents. B to the 6, b to the 2, I add the exponents. So my final answer is negative 27 over 2, a to the 4, b to the 8. Okay, I'm just going to erase my, just to make it a little cleaner. Did everyone follow that? How do you guys feel about this stuff? Do you need more practice, or are you okay with this stuff? Let me just give you a couple more. Just write these on a piece of paper, because that's it. And then we're gonna stop and we're gonna do some practice with. I'm gonna get you to do number 1. Okay, let's just do a couple more. How about if I said to you, okay, it's a completely made up one. Try that one. Okay, you guys all have enough time to do this one? So what did you do first? Did you simplify inside brackets first? Okay, so this becomes -5 m power 4. Do you want to put your n minus 2 or n underneath? Up, n minus 2, like that? Okay. And this becomes 2m to the minus 2, n to the 3 squared, right? Then I have to do this first. So this is just sitting waiting for me. So this is 4m to the -4, n6. Okay, last thing. Multiply, right? So I get my -20. What happens here? M to the power 0 and n to the power 4. So how would I record my last final answer? What happens to this to the power 0? It's just 1, right? So it's -20 times 1, so that's your final answer out of that whole mess, right? Okay, how about these guys? I want you to evaluate these 3 without a calculator. Okay? Should be able to do all of them without a calculator. You might have to use this rule. I'll give you a little hint. You might want to think of them this way too, right? Converting from an exponential to that might help you. I don't know. Maybe you don't need that. Give it a try. All right, this first one should be easy. What's 64 to the power of a half? 8, right? Because that's the same as saying the square root of 64. So that's why it helps being able to flip back and forth, because probably everyone knows the square root of 64, right? This one looks odd, but it's just, think of it as square root of 64 then. This guy's a bit harder, right? It's very difficult to deal with negative exponents. And there was a time when if you punched a negative exponent in your calculator, it would give you an error message, right? But I think they've been programmed differently. But you don't have your calculator, so how did you approach this one?
1 over.
Turn it into positive first? So in order to turn that to positive exponent, I can think of it this way, which already is better, right? So what would this, did everyone kind of then try to think of this as a radical? Yeah, so if I wanted to write that in radical form, it'd be the square root of 36 to the power 3, right? So then that's 1 over 6 cubed, which is, yeah, 1 over 216. So it's doable, right? What about this guy? No calculator, so it'd be hard to do 2 to the power 7 in your head, but you don't have to. Because you could say, well, that's going to be 2 to the negative 3, which is 1 over 2 cubed, which is 1 over 8. Perfect. Okay, you should be fairly adept at this stuff. If you need to practice a little bit, let me know. You'll have a bit of practice with working with logs and exponents. Not so much with these guys, but we'll have to just keep working at that. I'm gonna stop with the examples right now because I just want you to work on number 1 till the break. So if you look at page 226, and then we'll start talking about the next part of this lesson. So on page 226, just do number 1. Again, it says write the following expressions without brackets and with positive exponents only. I would really encourage you not to use any calculators, right? Just do this all in your head. So I'll give you to the break.